number 2 from chapter 27. This problem reads, in a Young's double-slit experiment, the angle that locates the second dark fringe on either side of the central bright fringe is 5.4 degrees. Find the ratio of d to lambda of the slit separation d to the wavelength lambda of the light. So we're finding the ratio of the slit separation to the wavelength. And generally, in a Young's double slit experiment, light passes through a pair of narrow slits and produces a pattern, and the pattern alternates bright and dark fringes on the viewing screen. And the angle that locates the mth dark fringe is given by this equation. So basically, if it's the 7th dark fringe, you put the 7 where m is, and then solve for theta, and that'll give you the angle that locates the 7th, or whatever dark fringe you're looking for. But in this situation, the problem is asking us to find the ratio of d to lambda ratio. Yeah. So which can be written as d over lambda. And conveniently enough, with some algebra, this equation right here can be rearranged to have d over lambda on one side. So you would multiply both sides by d, divide both sides by sine, and then divide both sides by lambda, basically. Then you get this equation. And with this equation, it tells us that, it gives us m when it tells us that it's the second dark fringe. So we're going to use 1. And the angle is also given as 5.4 degrees. So we put that in, put 1, and then 1 plus 0.05, 1 plus 0.5, excuse me, over the sine of 5.4 degrees equals 16. So the ratio of the slit separation to the wavelength is 16. There's no units on this answer because it's a ratio. So that's how you do chapter 27, number 2.